The technology the U.S. military used before the internet existed, before fiber optics, before email, before civilians could connect to anything resembling a global network, the United States military was already transmitting classified data across continents almost in real time. These systems were invisible to the public, unknown to historians for decades, and in many ways, more sophisticated than most people realize today. This is the story of the networks that came before the internet. The illusion of the pre-internet dark age. We often picture the 1950s and 60s as a disconnected world. Telephones were tied to walls, letters took days, information moved slowly, or so we assume, because the technology simply didn't exist yet. But for the Department of Defense, that assumption was never true. While American families gathered around their televisions to watch the evening news, military personnel were already using digital terminals to exchange operational data between command centers, separated by thousands of miles. The infrastructure was there. It just wasn't meant to be seen. The Cold War communication problem. During the Cold War, the United States faced a problem with no margin for error. Strategic decisions had to be made in minutes. Early warning systems detecting missile launches had to relay information instantly. Commanders in Europe, the Pacific, and North America needed to coordinate without delay. Traditional methods weren't enough. Radio was vulnerable. Telephones could be intercepted. Physical couriers were simply too slow. The military needed something faster, more secure, and resilient enough to survive failure. Because in that environment, failure to communicate wasn't an inconvenience. It was the difference between restraint and catastrophe. The hidden systems. The solution came through a series of dedicated classified communication networks built exclusively for defense. One of the most important was a system called AUTODIN, the Automatic Digital Network. By the early 1960s, AUTODIN allowed military installations to send and receive digital messages through a network of switching centers. Messages weren't sent as a single stream. They were broken into smaller units, routed through multiple paths, and reassembled at their destination. If one route failed, the data simply found another. It wasn't the internet, but the logic was unmistakably similar. At the same time, the military developed SAGE, the semi-automatic ground environment. SAGE linked radar stations, command centers, and interceptor bases across North America. Data from hundreds of sensors was processed by some of the largest computers ever built. Commands were issued in real time. This wasn't a prototype. It wasn't theoretical. It was a functioning, continent-scale digital network, decades before the word cyberspace even existed. What made these systems effective wasn't just hardware. It was discipline. Every message followed strict formats. Every operator was trained to respond within seconds. Redundancy existed at every level. If a switching center failed, traffic rerouted automatically, without human intervention. The speed didn't come from raw computing power. It came from systems engineered to work under the worst possible conditions. In many cases, information moved faster through these military networks than it would over early commercial internet connections decades later. Why civilians never knew. So why didn't the public know any of this? The answer is simple. It was classified. The locations of switching centers, the encryption methods, even the existence of certain terminals, all restricted. And there was also cost. These systems required entire rooms of mainframe computers, highly trained personnel, and infrastructure only a defense budget could support. There was no reason to reveal them, and every reason to keep them hidden. For decades, the most advanced communication networks on Earth operated completely out of public sight. By the late 1960s, researchers working on defense projects began asking a new question. What if networks could be more flexible, more decentralized? The lessons learned from military systems, packet switching, redundancy, distributed architecture, began shaping new experiments funded by the Department of Defense. The transition wasn't sudden. It wasn't one invention. It was a slow accumulation of ideas, many of which had already been proven, quietly, inside classified systems. When the internet finally reached civilian use in the 1990s, it didn't replace everything the military had built. Some of those older systems continued operating well into the 21st century. What the internet did was different. It took ideas that had been locked inside defense infrastructure and made them available to everyone. Packetized data, multiple routes, no single point of control, concepts that had already been working, unseen for nearly 30 years. The internet didn't invent them. It democratized them. Rethinking technological progress. We like to imagine technological progress as a straight line, invention, then adoption, then widespread use. Reality is messier. Advanced systems often exist in secrecy, long before the public learns they're possible. The gap between what can be done and what is publicly known can last decades. Many of the technologies that shape civilian life are first refined in silence, under pressure, far from public view. The internet didn't appear out of nowhere. It emerged from a foundation built quietly, methodically, and out of sight. The networks that carried America's most sensitive communications during the Cold War weren't just precursors to the internet. They were proof that long-distance, digital, resilient communication was possible, years before most people imagined it. The military didn't wait for the technology to exist. They built it because they had to. And by the time the internet reached the public, much of the work had already been done, quietly.